Hello and welcome to Semaphore Uncut, a podcast for developers about building great products. Today I'm excited to welcome Elton Stoneman. Elton, thank you so much for joining us.
Oh, thanks for having me. So I'm a return visitor.
Yeah, we talked roughly a year ago, but now we have some, exciting news around the areas of your work.
Yeah. So I'll do the new introduction for folks who haven't heard of me before. So I'm just releasing a new book. So the last time I spoke to you, I'd written a book about Docker, and I've just finished the sequel to that book, which is about Kubernetes. So I've done the first draft and it's going through all the kind of review process. So it'll be out at the start of 2021, but it's published through Manning and they have this kind of early access program. So you can go and sign up and read all the chapters now. So I was really keen to write this book. I've been using Kubernetes a lot and working with clients a lot for the last few years. And I think people get really kind of frustrated with the big jumps in the learning curve. Docker's fairly easy. Running an app in Kubernetes is fairly easy, but then configuring it and understanding all the other bits and pieces and the bits of the ecosystem you need to bring in, I think people get frustrated that there are so many jumps. So hopefully the goal of this book is to guide you from whether you're zero or whether you're, a relative beginner, to guide you through that whole learning curve of Kubernetes, to how people actually use it in reality and the other things you need to learn to be able to be successful with it. But, try and make it interesting as well. So that's the goal, quite an advanced goal.
Yeah. Prior to starting to record, we talked about generally the aim of the book and the audience and also the expectations it's setting. And I find it super interesting in how it's not in depth, but it's, as you already mentioned, it's trying to make things more approachable for people. So can you maybe give us a more in-depth overview on that?
Yeah, sure. So it's called Learn Kubernetes in a Month of Lunches. So Manning have this Month of Lunches series. My last book was Docker in a Month of Lunches. The idea is there are 20 chapters. It's very hands-on. So there's lots of exercises to do. Every chapter finishes with a lab for you to go and test what you've learned, all that sort of stuff. So lots of exercises to work through. But the idea is you should be able to go through the chapter in about an hour. So nominally in your lunch break, and then over a month, you'll have learned the whole thing. That was fine for the Docker book because you can focus on these little topics and in an hour, you can cover that in a lot of detail. So 20 topics for Docker, you can cover everything in a fairly kind of decent level. With Kubernetes, it's a bit different because it's such a vast topic. You can be learning Kubernetes for months and months and months. And what I wanted to do is kind of get that balance between teaching you enough that it's useful and giving you an authentic experience of using Kubernetes. You can use Kubernetes a lot if you follow through the exercises. Give you a real feel that when you've gone from this book, if you're completely new to Kubernetes, you can read this book, follow the exercises, and then, move on to a team that's using Kubernetes and be comfortable, be comfortable with what you're doing and how they're working. So it's trying to give you that kind of authentic experience. It's still broken down into each chapter is a self-contained topic, but I didn't want to restrict myself to say, each chapter's got to be 5,000 words. It's got to be 60 minutes. So actually the chapters are bigger. I do go into a lot of detail around those individual topics, but it always starts from somewhere simple with an overview, a bunch of diagrams, and then into all the exercises, and then finishes off with a kind of step back to look at what we've done. So yeah, I would hope it's kind of getting that balance of being approachable. It's not targeted at developers or operators or, Java people or .NET people. There are examples in all sorts of languages for all sorts of people from different backgrounds. So I'd hope it helps people on a learning journey, but at the end of it, it gives them something that they're really confident to go on with in their career, because that's the whole point of it, really.
Yeah, so it should make it much easier for people to get started and, as you mentioned, get hands-on experience.
Yeah, definitely. So I've been teaching Docker and Kubernetes at workshops and for clients for many years. And I really think that doing it yourself really, really helps. All the content for these books, all the source code for the applications, the Kubernetes manifest, all that stuff is all on GitHub. So you don't need to buy the book. Probably shouldn't say that, but you don't need to buy it. You can still work through and see how all these things work. And I try not to duplicate stuff you can find elsewhere. So I don't go into details about, all the YAML specifications for Kubernetes, because the API docs are the place to find that. So what I'll do is I'll say, here's a YAML file. Here are the 5 lines that are really important for this particular topic. And this is how you'll use them in production. This is what happens if you don't include this, that sort of stuff. And then go to the docs for the next level of detail. But, by then you'll be familiar with the core topics. So yeah, that's the way around it.
Hey everyone, Semaphore has published an open source book called CI/CD with Docker and Kubernetes. It combines just the right amount of best practices and practical advice for shipping cloud-native apps. Download your free copy today at semaphoreCI.com. What I can add to this story about learning Kubernetes is that, talking with clients, mainly on the topics of like continuous integration and continuous delivery, but you cannot not touch upon how things are running in production and what we should do prior to delivering there. And people that are usually sitting across are like, DevOps people, SREs, developers. And what I find interesting is that maybe it's almost 80-20 rule in terms of like people who are primarily focused 80% of their time on Kubernetes. For them, as you mentioned, learning Kubernetes for months and years and running it in production, it's a different experience and different perspective on the same technology and stack. And for developers, I feel it's like inverted. So 80% of your time you are focused on writing the code, and then 20% of your time you're focused on, okay, how is it running? Is it running? Or, in case of incident, what should I do and interact with it?
Yeah, I think that's a really fair point. I think there are different levels of kind of desirability of the knowledge of the tech stack when you're in those environments. And because those, the old definitions are becoming blurred. So, you don't have developers who have no understanding of operations anymore, and you don't have ops people who have no understanding of the build, especially, if you're looking at CI/CD stuff. I think that's all becoming blurred. You need to take that kind of step forward. That's what I've seen, certainly working with companies on like a consultancy basis. They have their teams. There's a real energy around learning this stuff, especially if you're coming from an older background. A lot of my clients have got Windows applications. They're maybe 10 years old. They're trying to work out how they move into the cloud in an effective, non-rewrite, non-vendor lock-in way. And Docker and Kubernetes is really attractive to that. But yeah, within that, I've got some developers, they're just going to be living inside Visual Studio. They hit F5 when they want to run the application. But for them to be able to learn that this is what it looks like in a container, this is why it's important that you structure it so that your application can read configuration from the environment. All you need to know is these few patterns for your application reading environment settings to know how to set itself up. And then when you're running in Docker or Kubernetes, then the platform configures the app, and you're kind of decoupling the package, which is your Docker image, your container image, from your runtime settings, which come from the platform. This is why it's important that your logs come out of the container, because then the platform can suck it all up. As an example there, and like monitoring your metrics of how hard your application is working, there's a chapter for each of those things. So even if you're from a dev background and you're not looking at those dashboards in production, if you follow the exercises through, and we spin up all this great stuff that's in the Kubernetes ecosystem, the EFK stack with Elasticsearch and FluentD and Kibana, which gives you centralized logging. So, the platform sucks up logs from all of your containers, and you've just got this lovely little front end that you can search for error codes or whatever. Seeing that outside of your own production environment, just with some simple exercises, seeing how all that works, I think really helps you understand how the pieces fit together. And if you are from the ops side, then that's going to show you how you're going to bring that stuff into your own environment, hopefully.
Yeah. Adding to this, how interesting it is for developers and generally how hard it is for them to get in. Some experience that I have, like helping people who are maybe just out of university and maybe have like actually, super solid, coding skills and, can just write fairly complex applications in their first few months of their careers, where it's usually rough and they feel quite uncomfortable from my experiences when it needs to be deployed somewhere, and then it's running for some other people to use that code. And those times where you need to okay, here is a Linux operating system and it's going to be running there, and the primitives that you got there are really on the very low level. That's usually a place where the comfort level really drops. I didn't have recent experience of introducing Kubernetes to people who are just starting their career, but my guess is that they will be more comfortable because there are more like high level concepts. I don't need to tail F with on this particular path, but some things are just defined. There's abstraction layer which is more approachable to me, as Docker is also.
Yeah, I think that's right. And there are multiple abstraction layers. There's the compute abstraction layer that defines how your apps run. There's networking abstraction. There's storage abstractions. And you can kind of go to whichever level you need to pull that stuff together. I've seen what you were saying as well in organizations of different ages. Effectively, there's this whole spectrum where some organizations have this platform that they provide for their teams, for their product teams. So, they're running Kubernetes and stuff behind the scenes, but you don't need to get involved with that as long as your applications fit the model. So, you package them up to run in a container image. They need to read config from the environment, write logs out, have a /metrics endpoint that gives you all the information that you care about. It's standard. doesn't matter what's happening inside the image, whether it's, an old .NET framework app on Windows or a brand new Go application. As long as it plugs into the platform in the same way, then they can completely take care of that. So the developers themselves might just work as in the Docker level, so I'll build my application, I'll do a Docker run to make sure it all starts up correctly and runs in a container, and then I'm done, and somebody else packages it up for me. Right to the other end, smaller teams and newer organizations where the devs know all that stuff as well, or want to know that stuff. That's the other kind of part of it. You hear a lot that people find Kubernetes complex and the learning curve is steep. And then you get the other people who love that stuff, who love being able to really dig into something, learn a new skill. It's actually a really great product when you dig into it more and more. You're getting a world-class platform to run your applications, and all you've got to do is learn some YAML, really. So I think people really like that as well. And I think there are these various points where you start learning these pieces that Kubernetes fits together for you, and you're wondering why it's so complex. You're wondering why there are so many abstractions layered upon abstractions. And then when you realize that, the reason you have a pod to run your containers is so that the pod can restart a container or replace a container. And you can run multiple containers in your pod, and that enables all sorts of different patterns. So then you go, now I understand why that abstraction is there. And that keeps happening as you're learning more and more about this stuff. So I think for people who are techie, whether you're, from whichever background you're from, if you like digging into the tech, then there's a lot there for you. So even though it is complex, the payoff then is that once you've learned your Kubernetes well enough and you know the management side of it and you know the modeling side of it in your YAML files, you can go to any project in your organization and pick it up straight away, and the other organization, and anywhere from joining an established team and running their stuff in Kubernetes to helping a new team bring their stuff to Kubernetes. Once you've learned the skill, you're done, and you can run that in any cloud, data center, laptop. It's that portability, I think, is really important career-wise as well as deployment-wise.
Hey, I'm going to take a quick break here and tell you that Semaphore has a new book out called CI/CD with Docker and Kubernetes. If you are looking to deploy cloud-native apps, it's going to show you the most productive way of doing that. And the best of all, it's free. Download your free copy today at semaphoreCI.com. Now that you are mentioning this, how easy it is to, let's say, move from maybe team to team or even from company to company, my initial experiences were like in Rails, and there was that, I don't know if it's maybe one of the first chapters in the book, like convention over configuration. So as you mentioned that, you are reading configuration from the environment. And Heroku was one of the first services that I ran into that had that, 12-factor manifesto, if I'm correct. And that essentially was then adopted in, I don't know what turn of events in Docker and now to Kubernetes. As you said, career-wise, it's great to have something like this. It's not that you are moving from company to company and then you're starting, completely from scratch and, learning something very, very specific, which you might not be able to apply ever in your life again.
Yeah, exactly. Yeah. Yeah, I've worked on lots of systems like that.
Yeah, absolutely. And talking through these layers and what do you need to grasp, what you might not need to grasp, depending on your needs and your position. Something we also touched upon were abstraction layers on top of Kubernetes. I cannot count. I'm not that deep into the Kubernetes community, but I kind of feel that there were a couple of attempts, couple of waves to bring some level of abstraction, to make it more approachable or to, simplify things. And you just mentioned the project from HashiCorp that was recently released, Waypoint.
Yes.
So can you maybe give us an overview how you see those previous waves of abstractions and why they're interesting and what's next?
Yeah. The thing that people find difficult with Kubernetes is that it's a modeling language. So I should probably take a step back. If people are not familiar with Kubernetes, you model your applications in this YAML file, which says, I'm going to run this number of this containers and we need this type of storage. And then the networking is how these things are plugged together. It's all described in these YAML documents, which can get big and difficult to work with. You can be talking with hundreds of lines of YAML to model this application. Payback of that, of course, you can run that anywhere, and it's effectively the same thing that you'll run in Azure or AWS or wherever you want to run it. You can literally take your app and spin it up somewhere else using the same modeling language. But you've got all those hundreds of lines of YAML to maintain. There have been several different attempts to either abstract that away and have a simplified layer on top of it, or to augment it in some way so you can kind of simplify it down. So there are projects like Case on It, which is an attempt to describe the modeling language in a different way. There are projects that can take Docker Compose, which is an alternative way of modeling your application for a container runtime, but much simpler, and convert that to Kubernetes for you. Waypoint is the new thing from HashiCorp, which is an abstraction layer across. It's trying to really give you that ability to model your application in an abstract from any kind of runtime, really. So with Waypoint, you could, in theory, you could model your application once. You can use that same definition to run it in Docker Compose on your laptop, and then take that to Azure and run it in the cloud. I think all these things are really interesting, but the ones that have kind of fallen away, it's just about the uptake. And sooner or later, you're going to have to dig down into the details. So I think if you've got a complex app to represent, the beauty of Kubernetes is you can represent it in all its complex glory in all those YAML files. So as an example, my background is all in .NET. And so the new version of .NET can run in either Windows containers or Linux containers. And you can have a Kubernetes cluster that can run Windows apps and Linux apps. If you've got a distributed app where some components have to be Windows because they're older, some components are new and they can be Linux, you still describe that in one YAML file. So you still model that whole thing. You say this component has to run on Windows, this component has to run on Linux. And then maybe, a lot of companies have a Windows estate that they really want to minimize. So they want to gradually, wean themselves off Windows. So they're moving some of their apps to Linux where they can, but they still have a requirement to run Windows. So let's say I've got my cluster of 20 servers and 15 of them are Linux and 5 of them are Windows because I need that subset of Windows estate. Well, I can model my application in Kubernetes to say these components have to run on Windows, these have to run on Linux, these here, they're cross-platform. So ideally, I'll run them on Linux because it's cheaper to run Linux machines in the cloud. But if I've got spare capacity on Windows, run them on my Windows machine. And so that's the sort of complexity I'm talking about. Like, how do you model that in a really simple thing that just says, here's the container image to use? So sooner or later, you're going to need to dig down into the detail, I think. And part of the problem is that there isn't a nice way to do that. So with Docker Compose, they're also trying to broaden that specification, allow you to have kind of optional stanzas that bring chunks in, but then you're going to have enough information in your abstraction to go down to the level of detail in the target model. And then you're either relying on, someone who is going to have that logic hardwired inside their conversion algorithms, or have enough flexibility in the specification to say, I can actually just take a lump of YAML and wage it straight into my simplified version. So I think that's part of the problem, is that people really want to simplify it, but it's not a simple problem. You can't just give people all the flexibility and all the configuration options in a simplified version, because sooner or later you're going to need to dig down in that, I think. Certainly, conventions that you can apply across the board, things like that make a lot of sense, but my feeling is they're always destined to have a smaller audience than the full modeling language. The people who can learn Kubernetes because they're planning to use it everywhere, going to learn it inside out, and they're not necessarily going to use a simplified version because it doesn't give them what they need. So a smaller number of people will adopt Waypoint or Compose with a goal to deploy into Kubernetes until they find there's something they can't configure, and then they have to make a choice. Do we use Waypoint for all our non-production environments and then a full Kubernetes specification for production? And then you end up with things getting out of sync. So yeah, I think the whole area is complicated. I can't see, unless it's exceptionally well done, I can't see an abstraction with the goal of simplifying the modeling language is ever going to work, because the modeling language is complex for a reason. It gives you all those features. So yeah, I'm interested to see how Waypoint goes, because all of HashiCorp stuff is great technology. So I'm going to follow that, but I'd be surprised if it has the widespread adoption of, a Compose or a Kubernetes spec.
Yeah. And at one point you mentioned that it will be like a smaller audience that will be interested in Waypoint. I would say, yeah, that would be the case. It's interesting how there are those cycles. So there comes AWS with, generally easy to get VMs. And then, at least in my experience, there comes Heroku with, 12 factor and makes a lot of things easier. And then it's also about the project, which should run there. So in the early days of running Semaphore, we used Heroku. But maybe, less than a year after, launching a product, we just felt too constrained. It's fantastic. It was fantastic for a lot of client projects that we did, but then you outgrow it. And then with Waypoint, it's also a question which companies and products will outgrow it and which will not. And yeah, in terms of cycles, there is also that there are those like vendor-specific approaches that, let's say, AWS, offers, like ECS. At some point, it felt that there is nothing else, at least, that ECS is the way to run Kubernetes in production. And then this wave of Kubernetes now change that. And then it's like layer upon layer and the cycle across cycle of like making things complex and then reducing it and making it more approachable. And then there's another cycle.
Yeah, yeah. Kubernetes is not the end, but I think something will come that does that in a simpler way. I mean, simpler is the thing I think that people want. If you look at the recent releases of Kubernetes, some of the stuff they're adding now, which is really neat stuff, like the ability to say, my web application runs in a container, it uses an API. So ideally, when it connects to that API, connect to the pod on the same machine, on the same node, so I don't have to do a network hop. But if you can't do that, then at least connect to the machine in the same region. And if you can't do that because there's none available, then go over here. Again, you can capture all that in the modeling language, but that's pretty low level of detail that you need to get to. And all the simple stuff has all kind of been done and done really well. So something will come. I would hope that thing that comes will start from the point of, well, you've got your application model to run in Kubernetes, and now you can take that and bring that with you. So, the complexity you're doing, which is what I've been saying when I've been working with clients who are right at the beginning of that journey of, we think we want containers, we think we want Kubernetes. We're kind of dubious about the fact that we have to remodel all our applications and, we have to package them in a different way and distribute them in a different way. And you're like, well, hopefully when you package your app or your application component to run in a container image, that should be the last thing you have to do, because then you can run that in Kubernetes, or whatever comes in the future is going to be a container platform for the foreseeable future. So I would think that, the journey that you're going to learn this stuff and then to apply it to your existing projects, I think that's going to future-proof you for a little while. It's interesting you say about ECS, because of course ECS lets you take the Docker Compose specification, and that's how they base that up. And Amazon have been involved with the Docker team to take that spec and make it more flexible, so they can include ECS specific stuff in there. And then this new thing that Docker have been working on both with Amazon and Azure, that you can take your Docker Compose specification and deploy it directly to their managed container platform. So I don't mean a Kubernetes cluster, because with things like Azure container instances with Amazon Fargate, the containers just run. You just say, I want this container running. You don't specify a cluster or a cluster size or anything like that. And so Docker are kind of taking the Compose specification and saying, well, you can deploy this to these PaaS-like container platforms without having to manage the cluster underneath. So I think all that stuff's interesting. And then it comes down to, are people going to be able to do that with Kubernetes and then cut some of the stuff out that doesn't make sense when you're in that managed environment? So yeah, I think there's going to be something, but I don't think it's going to be for a while.
Yeah, absolutely. Kubernetes is at a very nice stage, I would say, right now, because I think that if you wrote your YAML files 3 years ago and you get today a newest version of Kubernetes cluster, you can just apply those 3-year-old YAMLs with your containers. It will all just work. So having that, rock solid, stable, backward compatible API, which defines your YAML, is a great thing.
Yeah. If you listen to some of the big players in the Kubernetes community, they talk about the API, they talk about that modeling specification as the thing that you should care about. Because if you're setting up your own cluster, then you need to understand the internals of Kubernetes. You need to understand how you deploy your cluster and add servers, and how you do a rolling upgrade of Kubernetes and all that sort of stuff. But if you're running in the cloud, you kind of don't need to know that, because you'll just spin up a managed Kubernetes cluster with X number of Linux servers and X number of Windows servers. And when it's time to do a rolling upgrade, your provider will take care of that for you. You'll set up maybe some new nodes in the new version and gradually move your workloads over. But the interesting thing there is, you don't really need to know about the cluster underneath. So if you listen to Kelsey Hightower and some of the people who are thinking about the future of Kubernetes, it's about the API, and you will throw your YAML specification somewhere and everything will just run the way it always has, but you won't need to manage a cluster. And I think that's an interesting thing. Then again, that comes into, if you've abstracted away your Kubernetes YAML to something else, are you going to be able to have that option in the future? Or will whoever's providing that abstraction layer need to be on board with how that evolves? So yeah, the API is the thing. Like you say, you get the backwards compatibility. And then going forward, Kubernetes is just so big that whatever comes will have to be supportable with Kubernetes manifest. So I think it's a safe bet.
Yeah, absolutely. Maybe to wrap it up, if you package your application inside of a Docker container, you are good for the next decade for sure, or more. So if it's going to run in Kubernetes or not, but even with Kubernetes, you are like, from production experience of not running, but using Kubernetes cluster for 3 years for running Semaphore, I could say that probably in 3 years time, it will still run just great with the same YAMLs. So it's not as scary as it sounds. You need to take care of the majority of things once, and then, polish the pieces as your architecture or application grows.
Yeah, exactly. One of the great benefits is that stability with your API. And the other benefit is that because Kubernetes moves so fast and because the container images that you base your own applications on have their own life cycle of, being updated every month, it kind of forces you into regular updates. Kubernetes, you're going to need to replace your cluster every year because, they only have support for the previous, minor releases for 6 months. So you're going to have to get used to tearing down production and spinning up a new environment with the new versions. You're going to have to get used to the idea that an update of your own application means replacing containers. And then, you get into this idea that deployment is something that's streamlined and standardized and not scary because you just do it all the time. So it doesn't matter whether it's an update to the operating system image or the application platform that's had a new patch. It's all the same process to do the updates. It's all automated. It's all happens every day. So, I think that it just forces you to go down that route, and it means your apps are more secure and it's easier to deploy updates and everything just becomes nice and standardized.
Yeah, it essentially prevents all that rot and erosion that will happen.
Yeah.
Exactly. Okay, great, Elton. You mentioned the book is published by Manning, and we'll probably have some code somewhere or some links in the show notes. The state is that it's in the early preview.
Yeah, so all the chapters are written, so you can go to this technical preview. You can go to the website now. You don't even have to buy it. You can start reading the chapters online, and then if you want to, you can kind of buy it now. And as soon as it's released, you'll get the full version. All the chapters are there now. I'm just checking through. Everything is there for you to read, so it's all good.
Great. We're going to share those links. Good luck with publishing of the book.
Thank you.
And thank you so much.
Thanks for having me.